Assalamu alaikum. This is the first presentation of Group B, and the problem we have been given is internet networking problems and challenges. So basically, the internet networking problems and challenges can be divided into basic four categories, which are connectivity, reliability, and management and flexibility. So moving forward first to the connectivity issues, the issue is that we have to support communication between disparate and heterogeneous technologies, like we have WAN, we have WAV, we have telephone cable communication, etc. So the first problem is that there is different addressing schemes, so the problem arises between communicating between different nodes or different networks. So the solution to the problem is that we have a higher layer of centralized addressing of IP layer, and this solves the problem of addressing because all the networks are encompassed in this one higher layer. So moving forward, we have the packet routing. In computer networks, the packet routing is done using the packet switching, and basically which means that the different packets follow different pathways. So this could also create some problems, which would be discussed later on the reliability issues. So moving forward, we have some management issues. The management is intended to simplify the job of managing medium to large networks. The aim of management of network configuration management is to save your time and reduce errors on your network due to misconfiguration of network devices. Even if your network changes do cause error, it allows you to fix the errors faster. So modern networks, however, are very large, and manual configuration of hosts is a time-consuming chore. Furthermore, we often need to make use of features that only automated configuration can provide, particularly for special hosts that have no internal storage. It is for these reasons that host configuration protocols were developed. So we have host server configuration. Putting a host on an internet network requires that certain setup and configuration procedures be followed. We must perform configuration tasks that tell the software and hardware how we want it to operate and give it certain parameters so it knows its role on the network and how it functions. Over TCP/IP networks, we must want to tell each host some of the following, like we have the address of a default router on a local network, the network mask that the host should use, the address of server providing particular services to the host such as mail server or DNS server, and the host can successfully communicate with the server. So we have some solutions to these problems, which include TCP/IP bootstrap, feature filled dynamic and host control protocol, and TCP/IP standard management framework. We won't discuss these in detail because we haven't studied these yet. So moving forward, we come to the security issues. So basic concern of security issues, that is, we don't want people to be accessing our computers, we don't want people to get access to the data we communicate to the network, and we don't want malicious softwares to gain access to our computers. So the solutions to these include, like we have the firewall, which basically promises to protect your house and network from offensive websites and hackers. Then we have MAC based filtering of sites, address filtering. And then we have authenticate passwords, which mean that we can authenticate only certain users to our information. So moving forward, we have flexibility issues, which relate modern internet networking problems related for changes in the future. So we have flexibility issues include that a network should be capable of handling of modern technologies, like already existing or technologies that would come in the future, so to adopt properly, like we have WiMAX, we have voice over IP, we have IPv6, and the modern network should also be able to adapt to modern security needs. So moving forward, we have reliability issues. So the problem is that since there are different networks paths that the data could follow, as discussed earlier, so when the data comes, there is no guarantee that it follows it comes in the same sequence, because a different path could have different delays. So we have to add some sort of information to the packet, like we add this in the form of process header, which has a sequence number, so we can tell the destination host what is the proper sequence of the information that it receives. So what it does is that basically when it receives information out of order, like in this case, so it could rearrange the information to the proper sequence and get the data in proper order. So moving forward, we have different maximum packet sizes of different transmission media. And basically when there's a need, the router could either break down the data into the smaller bits or recombine the smaller bits into bigger data as requirements of the certain medium of transmission as is the requirement. So moving forward, we have data corruption, in which what happens is that the data is corrupted due to some channel noise or etc. And basically it is that the information that we require at one end is not reliable. It is not the same information that we transmit, and Basically, for this reason, we add redundancy in the data. For example, we have displayed a simple code of Hamming code and for data redundancy, and this is an illustration of how it works. Basically, so what it does is overall that we could sort of detect and correct 1 bit of change in the data, and so this is shown of how it works in the illustration data. And then we have a timeout positive acknowledgement mechanism to avoid data loss. So what the principle of mechanism is that when the destination receives a packet, IP packet, and properly receives the destination, resends a positive configuration to the source, and the source knows that the destination has been data has been sent to a destination properly. So for example, if the data is blocked, so you'd see that the positive configuration doesn't have the source, and source waits, and the source retransmits the data. But for example, it receives the example at a later stage if the destination the pathway is opened again, so the destination receives the 2 bytes of the 2 packets of the same data. So there is redundancy of the data. In this case, there is duplication. So the host source knows this because there is there is a 2 times acknowledgement of the same data. So it tries to remove this duplication by adding some mechanisms like windowing, which are also more advanced for our case. So finally, we have this problem of different transmission rates, and what happens is that some networks have fast transmission and some networks have slow transmission rates, and there is a problem of there are not enough buffers, limited buffers available. So what it does is that it tries to manage the queuing. It tries to manage the proper queues available. But for example, in this case, you see that there is the buffers are not enough, so some data is lost. So we could use the previous method of positive acknowledgement to solve this problem, and we also have an addition mechanism like flow control. We could help to use this solution to this problem. So with this, we come to the end of our slide, and we have the references I mentioned over here, from where we took for our information, our images, and etc. And these are the credits of our presentation, and hope it was informative enough, and hope you enjoyed it. Have a good day. Thank you.